to put 2, 3 decimal places. Otherwise, you can't really find the value.
Thank you.
Yes, because this one, like what they're saying, what she's saying is true. So it's 1.42. So what's the value we get here? It will be 0. What if we add that? It will be 1 minus 0.9 what? Nine, 2, 3, 6, 4. Like that. From the table, you might get a value slightly different. Now we together. Clear?
I got a different value.
I said it might be slightly different. That's what I said. Because I'm not using a table, so the values might be slightly different. Now let's look at the B part. Don't worry, you get used to the table. We want probability that X is what? X is less than what? Less than 5. And remember, from our X graph, or the distribution of X, we said the mean is 6. Like this. But 5 is less than 6. So 5 will be somewhere here. Okay. So now we have to normalize this first so that it follows a Z distribution. Okay, where this is 0. So to do that there, we use the same formula X minus, so Z is equal to X minus U over S. So which is our expected is 5 minus the mean, which is 6, divided by 1.4 is our standard deviation. What value do you get there? So that we know what that value is, definitely a negative value. What value do you get? What value do you get?
Minus 0.71429.
Minus, you said minus what?
Minus 0.71429.
0.71.
429.
So let's say 4. Now what I would encourage you is only give your answer to 4 what? Decimal places. Huh? So 429 is 4 what? 43 like this. Huh? All together. So that's the value that we want here. But remember we're saying, so we want the values less than this. Huh? Less than 1.0 point something there, which is okay, less than Z. But look at this. From what we said is our probability, unfortunately, cannot give us negative values. Huh? So we do symmetry, like what you said. That's why I was explaining that when we started the lesson. So this value here is the same as 0.7143, this other side. Huh? And this area that we want is the same as that area here. And to find that area, your graph can only find this area. So it's a 1 minus probability of the positive of Z being less than 0.7143, which is equal to 1 minus phi of Z, 1 minus phi of 0.7143. So, let's go and now and find the probability of that. That's all we are doing. 1 minus the probability of phi means probability of this. So let's go to 0.7143. What is that? Show me your probability. Tables now. Let's see what you get. What do you get? 0. So I want you to find phi of 0.7. Everyone should now know how to do that. Quickly, using a probability diagrams. I think there's also a way to do it. So go and research how to find it on a Casio calculator. You can do that, I'm sure. They also have those tables. What answer do we get, Maxine?
I got 0.119.
No. 0.7. 1, 4, 3.
I got 0.8811.
0.811.
8811.
I use incorrect. How come I've got 0.7625? I use incorrect tables. MF9. Let's see. Are you guys using correct tables from your syllabus? Did you go to 0.7 first? Okay, can we all go to 0.7? Can you see that 0.7 is starting from 0.7 something? I'm sure you saw that. Huh? Then we go to 0.71, where it's intersecting there. What value do you have so that we see if we have the same table?
0.7611.
0.7611.
11.
Then what did you do after that?
I went to the add
Additional
column.
yes. So you said,
And
we said 0.7, let's say, or the one that you gave me just now from your table, 0.7.
611.
611. I hope we can all agree there. I don't have that table. Then you went to the additional column, yes?
Under 4, then I added 0.12.
0.12 like this.
Yes. 0.12, and then I kind of stopped there.
Or it doesn't have the fourth decimal.
There's what? My number is 0.7143, so I guess we could have added again from the 3.
Do you have the extra
column.
additional on the yes?
It would be 9.
You mean 9 on this?
Yeah.
Okay, I don't have the table. Do you agree with him? So what value do you get if you do that? Maxine, I don't know how you're doing it to get your value. So what's the correct value? It's not difficult. What's the correct value? So if you add what you said, what do you get? 10, 2, that's what you're saying. Carry 1, 2, 3.
0.76320.
Okay, which is not far from what I have here. Was I said 0.625? Huh? You added a 9. Because I have 0.26. Okay, let me see. Someone send me a copy of. Are you using the standard, the one that you use for the exams? No, I'm just checking. If you are using the standard. No. The one you use for your exams. Is that what you are using? Okay, let me just check quickly. Your MF tab, I might have it somewhere. I remember saving it. Didn't I send you guys, some of you? Judith, I sent you before. MF9. MF9. How come I can't find it? Okay. I'm not sure what happened now. So MF, okay, sorry, my apologies. I need to find it so that we are on the same page. Then what I would encourage you, if you've got a Casio, you need to learn how to do it on the Casio. You are allowed in the exam to use it. If you struggle with these tables, yeah. But you should not struggle, you should know how to use tables.
So there is meant to be an extra add column for the fourth decimal place.
That's why I was asking. Yes,
I
for me.
didn't give us a table with an extra.
You mean a table? You get the table from the standard. That's why I was asking. Does anyone have the standard from the syllabus? Let's see. Add 0. What? It's like we don't have the fourth column. Huh? Seems as if we only have 3 columns. No, we don't have from your syllabus. It seems as if you only have, so it means we simply round it to 3 decimal places. That's what it means. So 0.7, it's 0.6, like what you said, 0.7611. Yeah? Then you simply have to go and add the 4 there. So there's no need to add this 9. Yeah? It's not there. How to get that in? Clear now? Because the 1 to 9 is for this third digit. Are we together? Makes sense? So we only round it to 3 according to your syllabus, according to the table that you are given. You can't do that, but your calculator will be more precise. Clear now? Hope it makes sense. You guys are quiet. Is that making sense? Or not making sense? Now, next question. Okay, write it down. Machines produce. Is Tawana still there? You are saying it's network. Produce both which are normally distributed with a mean of 4 and 0.09. So this means this is your variance, where measurements are in millimeters. Measurements are in millimeters. Both are measured accurately. Are measured accurately. And any bolts less than 3.5 millimeters or bigger than or larger than 4.4 millimeters are rejected. out of 500 votes, how many would be acceptable? How many would be acceptable? Good question, huh? How many would be acceptable? How many would be acceptable? So what do? We want to find, what's the first thing to this solution? Is to find the probability. Remember, we can assume that X follows a normal distribution with 4 and a variance of 0.9. So if you read the question, if we can't accept, if we can reject, we can work with the rejection first. Okay. Because we know that acceptance is simply 1 minus rejection. Now, probability of being rejected here is probability of what? Of being less than 3.5 or being what? Less than 3.5. I want to put it, I just want to do it slowly. Or probability of X being greater than 4 point what? 4.4. Are we agreeing? Makes sense? Probability. Hope is making sense now. Of which we can combine this probability. I simply wanted to show you. So this is probability of 3.5 less than X, X less than 4.4. Making sense now. Does that make sense now? I hope it makes sense. The first step. Now let's go and draw what everything, I hope you have written down the question. Let's go and draw everything that we have said. And not under the Z, but under the X distribution curve. So what is our mean from the question? Our mean is what? Is 4. And we said we are going to reject both 4.4 and both less than what? 3.5. So it means this region here is what we want. But we have to normalize this. Huh? We have to standardize it. That's what I mean. So if we want to standardize this 4 now is 0, like what you said. To find this value here, so we have to find these values. To find this value, we now use the formula Z is equal to X minus mean divided by standard deviation. So in this case, it's Z is our expected. On this one is 4.4 minus the mean, which is 4, divided by, what is the standard deviation? The variance is 0.09. So it's square root of 0. What? 0.9, like this. What do you get? What do you get?
0.3.
1 point? Give your answer to 1.3.
0.3.
0 point. Only 0.3.
That's the root of
Oh, okay. No, I mean the
0.09.
answer. Oh, okay, I get you. Okay. I mean the answer for this. I'm waiting for the actual answer for Z. This Z value here.
1.333.
Let's round it to 3 decimal places so that it works for a table. 1.33. Yeah? So this is 1.33. Now let's work the Z value there when it's 3.5. So the Z value is 3.5 expected minus the mean, which is 4, divided by 0.3 or square root of that, like what you said. And what do you get? Negative what?
Negative 1.67.
1.67. So this is negative 1.67. But we simply want the area under this. And we know from geometry, we said when we have this range, it's as good as what? Who remembers? We simply said phi of that. Okay, that's why it becomes tricky now. What did I say there? So phi of what? Let's see what you think. Phi of what? So if I want, I can find the phi of this will give me all this area. But remember, I need to take away this small area. It makes sense. Because from this is easy because this area here is greater than that area. Can you see that? I'm working the greater than. So the greater than of this area is this all the way. But I have to subtract that. I hope it makes sense there.
Aren't you meant to leave the values to 3 decimal places?
I'm working with, no, I'm working with, yes, I left it 3 decimal places. Didn't I give you 3 decimal? Oh, sorry. 3.3 here. I don't know what I was thinking. We should give it to 3 decimal places. And what is this answer here? 0. What? Negative 1. What? 1.67 what?
667.
So I'm saying what's 1.667. Okay. Yeah. 1.667. Sorry about that. So we should work with the 1.667. Hope it makes sense now. So, does that make sense? So what we are saying here, I'll show you what it means. It means, remember, I want the area to the less of this. So I'm saying phi of what? 1.333, like what you said, minus phi of, remember, if I'm taking the area of this, it's minus 1.667. Clear now? Phi of this, that it gets you this, then phi of this negative there, which is the same as what? Phi of a negative value. Look at this. Because your graph doesn't give you a negative value. Oh, sorry about that. So your graph doesn't give you a negative value. You think of the positive value of 1.667. Huh? So is this area that you need to take away. So if you need to take away this area, it's simply what? We talked about it. 1 minus what? So this here. So it's phi of 1.33. Now let's do this. So it's 1. So it's minus what? Remember what we said. If you want this, we're saying this here is the same as this. So it's 1 minus phi of 1.667 like this. That's what I meant like this. That's clear then? Makes sense? So can you find this? What values do you get there? 1.33 from your calculator. Let's see if you get an answer close to what I have here. Phi of 1 point that. What do you get? 1.33. Let's go to 1.3. Evan, we go to 1.3. Maybe I'll show it here. But I think almost everyone now knows how to do that. So I've got a table like this. So we go to 1.3, which is somewhere, it should be somewhere there. 1.3, because I think it gives you that. Then you go to, there's 1, 2, I think there will be a 3 there. Then you go and look for that value there. Then you're going to add on the additional, you're going to add the whatever you get there. Let's do that. What do you get? Values, what do you get?
0.9087.
0.9087. Looks like it's correct. 0.90887. Okay, that's fine. Minus, okay, 1 minus. Now what is, go and look for 1.667. 1.667, what is it? 1.667. 1.667, what do you get?
Zero 0.9522.
0.5?
9522.
You said 0.9.
Yes.
522. Okay, that's fine. What do you get there? So what's the whole answer when you do that? What do you get? 0.8 what? The final answer.
0.8609.
Yeah, but yeah, it put 0.86078. I think they just use a different table. So 0.8609. Okay, correct. Is that clear now? Now let's look at the exam questions now. The actual exam questions, what you get. Distribution. That's what I was looking for. Maybe. Something is sorry about that. I need to load properly. Normal distribution. Just wait a moment. Since is if. Also, this is 4.31 now. Okay. So 43 point. Okay, that's fine. So I will 4.31. 43.1. Okay. Yep. There we have some past exam questions. Okay, there. Oh, come on. Nice software. That's some fun stuff. Not this time. Just bear with me. Try to sort it out. Looks like it's correct now. Okay, there we have it. A farmer finds the weights of sheep in his farm. Okay, finds that the weight, okay, of the weights of sheep in his farm have a normal distribution with a mean of 66.4 and a standard deviation that. So the first thing that you do is you can let any letter, they are like using x. X follows a normal distribution. What is the mean there? 66.4. And the standard deviation, so it means 5.6 squared. Okay, clear now? Though there's no mark for that, it's just to help you. Now, 250 words. Ships are chosen at random. Estimate the number of ships that have got a weight between what? You see now? Between that and that. Between 70 and 72.6. Okay. So, I always like to do this because it helps you. So, to draw then we standardize. So, what is our mean here? 66 point what? 66.4. Everyone now knows this. Then what is the first part? We want a weight between what? Between these two. 70, both of them are above what? Are above that. So we have our 70 there. Then we have our 72.5. It's simply this area there. Clear now? Now, to standardize it, so what we simply want from this question, anyway, we talk about the probability, then we'll multiply by 250 first. So the first thing is to find probability. So one probability that Z70 is less than X, X is less than 72.5. Then we multiply that probability by 250. Does that make sense? That's how easy that is. So we simply want to find this probability. So now we now know this, but it's not standardized. So we have to standardize it. Okay. So to standardize, so this is 0. Okay, I'm not sure how I'm drawing this, guys. So this is 0 there. So we need to know what 70 is when it's now following Z distribution. So what Z is, what Z1 and Z2 values are. That's what I mean by that. So let's standardize that. To standardize that, we know that Z is given by the formula X minus mu over that. So let's start with 70. So it's 70 minus, what is this? 66.4 divided by standard deviation, which is 5.6. What do you get? Give your answer to 3 decimal places, like what we're doing. Can we use our calculators? What do you get?
0.643.
0.4
643.
0.643. 43. I hope we agree with it. So Z1, like what you're saying, is 0.643. Okay, I'll just call it Z1, Z2 here. Now Z2 here will be, this is 72.5. So 72.5 minus 66.4 divided by 5.6. What do you get?
1.089.
1.089. Okay. So it means there, because we now know these values, this is now Z. There's now the probability of 0.643 less than Z, Z less than 1.089. This is easy because this is all both are positive. Huh? So if I do phi of this minus phi of this, that's how easy that is. So it's simply phi of 1.089 minus phi of 0.643. So let's go to and find phi of 1.08. 1.08. I'm sure you have 1.0 there on your first thing. Then you go off to 8 there. Then you look for that value. Then you add an extra digit on the 9. So let's do that quickly.
0.8620.
0.8620
Yes.
minus, let's go and find 0.643.
Mm. 0.7399. 7399.
What did you get when you subtract that? That's the probability. That's the first part. What
0.1221.
0.1221. Probability multiplied by the number of sheep. Huh? So if you multiply by 250, what do you get? Because that's what they want us to estimate.
$30.
Sorry? What do you get?
30.
30.
Yeah, it's 30.525.
0.5. Okay. So it's simply 30. Okay, that's fine. Clear now? We can't have fraction of sheeps, which is correct the argument there. Now, let's go to the next part. The proportion of sheep weighing less than 59.2 is equal to the proportion of sheep weighing more than Y. Proportion, fractions, percentages. So probability of X being larger than, less than 59.2 is equal to proportion of what? Of probability of X being greater than what? Being greater than Y, yeah? So this is just a simple way to know your distributions. Huh? So now if we look at that curve there, anyway, like this. What is our mean for this? If you read again the question, 66.4. And this value here is less than this. Huh? So it's 59.2. Huh? So if we're saying less than is this region, can you see that? And the more than region, which is easy anyway, they are simply talking of this area, which is symmetrical to this. Makes sense? This area here. So it's the same, this here, because this gives us a negative value anyway, is the same as the probability of that being larger than this value here. Okay, now let's normalize it. We are almost done. So what is the Z value there? Z is equal to X minus me over that. So it's 59.2 minus 66.4 divided by what? 5.6. What do you get? What negative value do you get? 59.2 minus 66.4 divided by 5.6. What do you get? $59.2 minus 66.
Negative 1.29.
Negative 1.29. Okay, so we know that in terms of our, we are saying negative 1.29. Now it should give you answer to what? To 3 decimal places. That's what we said. So negative 1.2 what? 1.286. Huh? Negative 1.286. We want this area here. But we're saying symmetrical is the same as this area here, the positive 1.286. But we know that your graph only gives you this. So it's simply 1 minus phi of 1.286. I simply mean 1 minus probability of Z being less than 1.286 from this. Clear now? So what is that? What is phi of? Let's go and look for phi of 1.286. What is phi of 1.286? What do you get? 1.286. What are you getting? What's our value? From your booklet, 1 point, what do you get? 1.36 normal distribution. So I'm sure you went to 1.2. Then you go to 8 there. So what value did you get? 0.8.
0.9008.
0.9 what?
008.
Yeah, then you add, then did you add the 6? When you go to the 6, the extra digit there.
Oh, the 0.9008 is like the final.
Oh, it's the final. Okay. So it's 1 minus 0 point. What is your final answer? You said 0 point what?
9008.
Okay, like that. This is correct. Then you simply get your answer there. 1 minus that, which is 0.0 something. Okay, now let's go to the next part now. This is where it can become tricky to some of you, but it's not difficult. Those are the questions that they like there, these questions here. Even in June paper, there's questions similar like that. Okay, now a farmer finds that finds that the weights of the sheep on his farm have a normal distribution. Okay, now we are not even told we now need to do the opposite of what we've been doing. So normal distribution, we don't know that. Standard deviation 4.92 squared, like this. Okay, and that what? 25% of his sheep weigh more than what? More than that. Okay, let's think of what we are given here. Let's try to analyze. It's the opposite of what we've been doing. So now we don't know this. Then the other thing is we don't know if this 67.5 is this side or is that side. How do we use that? We use this answer here, which is saying what? 25% of the what? Of the sheep weigh more than what? 65.25%. So remember we said your probability is what? Is 100%. It's what? We said the probability. So if it's 25%, where would the 25% be? It's more than that, 25%. So is it this side or is it that side? Remember, this is halfway, 0.5, but I'm saying 25% being more than what? Being more than this, which means 75% is less than this. Are we agreeing? Make sense? 25%, only 25% is more than that. So 25%, the only way I can have 25% is when I have it somewhere, maybe halfway there. This is, so I'll say roughly this is my 25%. Like this. Hope it's making sense now. 25% is more than this. So this value here is here 67.5. 25% is more than that. Clear now? Now, if we were to find that, let's say we were given the mean, we would say probability of, you saw that, X is greater than what? 67.5. Are we agreeing? That's what we would say, probability that this is greater than what? Than that. Making sense now? That's what we would do, okay? But at the same time, we know that this is the same as what? We have to normalize this. Now, when we normalize that, because we don't know this value there, that's why I'm coming there. So when we normalize this 67 point whatever, we have to use the same formula. Z is equal to X minus mu, which is what we want to find, over what? The standard deviation. And our value here is 67.5 minus the mu that we want divided by, what is our standard deviation? 4.92 is equal to Z. Now we have to think about the Z now. Our graph only gives us this side. Do we agree? That the graph never gives us the more than side. It gives us the less than side. So if we're working that, it will be 1 minus the probability of what? Of Z being, if I were to put that way, of Z, or let's say of X. Let's work with X first so that you see what I'm talking about. The probability of X being less than what? Being less than this value. So if it's less than this value here, because you're saying 25%, what percentage is this value here that is left out? What percentage is this value? Isn't that 75%? This value is 75%. Is that clear? It's 75%. So now what you simply need is this Z value here, okay, that we are working. Remember, we're saying X bar minus that minus mu is equal to zeta. So when we are normalizing it, we are actually using 75% because we're saying this. That's what I've shown you. So now we want to do the opposite now. Remember, your table is like this. We want to go and look for 0.75 and find what that is in terms of probability. So can you, so that what is the Z value when you have 0.75? Let's go and look for 0.75. That's our Z. 0.75. Use your tables. Now you are doing the other way. Those you are not finding. You are given the probability. You want to find the 5. 0.75. So 0.75, I have 0. Look, we have very, very close to 0.75. Or the one maybe where you add 1 and the 0.499 or something. 0.75. Do we have a 0.75? I don't see it. But I see a value is very close to 0.75. So what's the best to work with? It's 0.75. Who can tell us there what have they found? Zero 0.75, one no, we want 0.75. 0.7. 0.7. 0.7486. So which means I need to add 14. Can you see that I've got a 0.786 there? I'm just giving an example. On if I go to 0. Do you see the one that I'm talking about? 0.786. If I go to, if I go to 0.6 column. Yes, to the 0.6 column there, then on 8 there, like 0. Can you see what I'm talking about? Then you simply add 14. Where do you add? Do you see what I'm saying? If you go to the 0.6, then you go to the column going down on 6 there, like 0.66. Isn't that 0.784? 0.486. Is that correct? 0.486. Do you see the value that I'm talking about? Go to 0.6, then go across the row until you're at 6. Is it 6 or 7? 7. Huh? Do you see what I'm talking about? I think this is 7. Yeah. This is 7, 8. Sorry. Whatever. Okay. Anyway, 0. Go to. Did you see what I'm talking about there? You guys, yeah, quiet. You go to 0.6, then you go to column 7. There is 0.7 what? 0.4786. So all I need is to add 14, which means I can add the 13 there. It should be a very close answer. Can you see that? And the 13 is on digit what? On digit 4. I hope it's making sense. So it will be 0.674. Are we agreeing? Maxine, are you lost?
So why haven't we gone on the 0.7 on the Z column instead?
0.75. No, we don't do that. Because this is the probability here. Are you together?
Mm-hmm.
It's the opposite. So you go inside there and look for 0.75 or something very close to 0.75. That's where I went to that value there, which is, well, that's why I said is go to 0.6. If you go to 0.6 there, then you go to that column 6 there, it's giving you something like 0.7486, which means I simply need to add 14. So my answer there straight away, I know that straight away is 0.6. Then this column is what? Is 6. I'm doing the opposite. Then if I go to the additional column, there's a 13. If I add the 13, it's as close to 0.499, which is very close. Can you see that? That's what I meant.
Okay.
The opposite. Are we together there? Because we are not finding the probability, we are given the probability. That's why I say 75% like this. Then we are simply substituting like this in the formula. We're simply saying 0.664 is equal to 64.5 minus mu over 4.92. Then you cross multiply. So you're saying 0.664 multiplied by 4.92 is equal to 67.5 minus mu. Then the other way, mu is equal to 67.5 minus 0.664 multiplied by 4.92, like that. Clear now?
Isn't it 0.674?
Okay, let's do number 2. It's similar. It will make sense just now. Now we have time x, the time x hours for which people sleep in one night in a normal, as a normal distribution with a mean of that and a standard deviation of that. Find the probability that a randomly chosen person sleeps for less than what? 8 hours. Huh? So probability that x is less than 8. So if you want without drawing the table, by the way, you can simply do it like this. Probability z, you can normalize it straight away, is less than x. Remember, I'm using this formula, x minus that over that. So it's 8 here minus, what is our standard deviation? Our mean, sorry, 7.15 divided by, what is the standard deviation? 0.88, like this. And what do you get? Probability that z is less than, is a positive. What's 1 minus 8 minus 7.5 divided by 0.88. What do you get? To 3 decimal places. 0.9 what? Maxine?
0.966.
966, like this. So remember, now because this is less than, if we're to draw a normal distribution, it's easier because your graph always gives you the less than. So it's simply phi of 0.966. Now we are looking for the probability. We now use the normal way, where we need to go to 0.96, then 6. Let's do that quickly and find what that is. So it's easy. 0.966. Zero 0.81, 0.8. Plus what? I hope I'm correct there. Just is I might be not correct because I'm using a phone. So are you getting something like this?
0.833.
0.8330. So that's the answer then. Done. What's the probability? Now the next part, you see, now we are given the percentage. Find Q. So we don't know what Q is, but we know the percentage. Okay, is equal to what? 75%. 75%. So what do we do? That's where it becomes tricky now. We use this. Okay, we can do it, but the trick, you have to be careful now. So look at this. I want everyone now to understand this. Now, what is this? It's 7.15. Huh? That's what I mean there. We know that the whole area is what? Is 1, huh? Which means probability of this side here is half. Are we together? I hope everyone is listening. Probability of this is half here. Then probability of this one is there. So this is 0.5 of this whole graph, because this whole graph is C1. And this is also 0.5. But we want what? Probability of Q of X being less than Q. X being less than Q is 0.7 what? 75. So where will be your Q? It can't be here because I can't have 75% there. Makes sense? So if it's X being less than 75%, it's half of this and a quarter of the, can you see that? That Q is definitely there. And we want this probability here. Probability that it's less than what? Wait a moment. Probability that X is less than Q is 0.75. X being less than. Oh, so that's not correct. Yeah? X being less than, okay, is 0.5. 0 is 3/4 of the graph. X being less than Q, huh? So it's the other way. So Q is here, is above, because if it's X being less than that, it's all this region here. Hope it makes sense. 75% of the graph, huh? Clear now? So our Q is a positive Q there. And I simply wanted to so that you know this. Anyway, from this now we can normalize it if we want. Huh? So its probability now is that Z is less than whatever Q is minus, what is the mean? 7.5. 7.1 divided by the standard what? Standard deviation, which is 0.88, like this. And that is giving us a probability of what? Of 0.75. Clear now? And if it's phi of this helps us. Huh? Otherwise, if it was a negative, we had to do something here. So we now know that it is a positive. So it's simply phi of this, if it was phi of Q minus Q here minus 7.15 over 0.88 is equal to 0.75. Okay. But this is a probability. We are given the percentage. So now we have to do the opposite of what we've been doing. Huh? Because this has been done for us. We need to look for 0.75 here. Are we together there?
So sorry to bring you back, but then I'm a bit confused about the graph that you did, like the x's.
Okay, let's go back. Okay. Let's go back here. So that otherwise, if you don't master this now, the questions can be difficult. Okay, let's go back. Okay, there I'm sure you now understand this first pattern. It follows the normal. Okay, let's try to draw the normal graph for you. This is not the standardized graph. Huh? This is the graph of X. So we're saying that what is the mean here? It's 7.15. Clear now? Let's go to this question here. It's saying find, let's go, if we had gone to this, it's saying 8. 8 is above what? 8 is above 5. Huh? It's about 7 point whatever. So it's easy to know when you are given a value. But now we don't know what Q is. So we have to identify whether Q is the left side of your mean or is the right side of your mean first? So let's read the question. It's saying what? Find the value of Q such that probability of X being less than Q is 0.75. And I said the area under the graph, that's what we said. This whole area under the graph is equal to 1. And this is half of it, it's 0.5. And this is half of it, is another 0.5. So if I'm saying probability of a certain number, look at this. Okay, let's explain something here so that we all agree. If I shade this, I'll do it slowly here. If I shade this whole area here, is the probability of Z, okay, or X being less than or equal to 0.5? Is that clear there? 0.5. Because the other section is also 0.5. But now I'm saying 0.7 what? 0.75. That's why I said because it's 0.75, it's this 0.75 plus another 2.5. That's why I said the logical answer is Q is greater than what? Is greater than 5. Does that make sense now? Because I'm saying says 0.75 like this. Hope it makes sense now on the graph.
Yes, thank you.
Okay. So that's why, that's the first thing we had to identify. So that's now why I'm now saying probability of Z being less than that. Now I'm simply saying it's Q minus, because I'm using the formula X minus that over that. So it's X minus 7.5 is divided by that is equal to that. And we know that since it's less than it's okay, it's simply phi of whatever value we get here is equal to this. So what we now go and look, this is the probability. We are now going to our table and looking for 0.75 there. But we can't find 0.575 like what we have done before. So go and look for what you add. Or very close to 0.5, to 75. I think we had used 0.6. I said 0.66 gives you 0.784 if I remember. Oh, I was lying. If you go to 0.6 then you go to 6, no, to 7, I think. 0.67 gives you 0.77486. Then if we add the extra digit on the 4 there, so you find that this here will now be Q minus 7.15 over 0.88 is equal to 0.674. I hope everyone is clear there. Because if I add that, if I go to this 0.667, I'm getting an answer like this, 0.864. Then when I go to this 4 digit, it has 13, like this. And if I add, is that correct what I'm doing there? I'm lying, huh? So that's not correct. We want 0. Oh, it's 0.4. Okay, I didn't write that correct. So it's 0. What? Yeah, it's correct. So it's 0.486 like this. You go to 0.6, the column on 0.6 here, then you go to the 6 here, you find this value here. Then if you go to the 4, the extra digit on 4 there, you are adding 13. So this will be 9. That's what I meant. 9, 4, 7. It's very close to 0.75. So that's why I'm using this value here, 0.674. So let's simply cross multiply. So it means Q is equal to 0.88 multiplied by 0.674 plus, if you move that the other way, it's 7.15. Hope it's clear now. And what do you get? I hope you are all on the group, but sometimes I will send some video links also to help you with the revision. If you are not on the WhatsApp group, ask the admin there to add you on the WhatsApp group. What do you get? 7 point what? 7.74. Clear? Let me show you something before we wind up from this year's June paper. Just one question so that you see what we are talking about. 6-1 paper. No, yours is a 5 paper. Okay, let's look at the match. We'll just look at question 1 to do normal distributions from the match paper. Then we wind up. Okay, then. Awesome. There. You see the question? Is we are not even given the standard deviation. So we can say X follows normal distribution, mean 82, and the standard deviation. Okay, then we say S bar squared like this. Then we want the probability of what? Of being greater than. Okay, so this is easy, but anyway, we know that this is greater than mean. So we now want the probability that X is greater than 87. Now, if we were to draw this quickly, the X graph, our mean is what? 82. Then our 87 would be somewhere here. So we are saying we want the probability of being greater than, okay, is this region here. Clear? And we know that this region, okay, we are told that the 22% like this, we are actually told this, have a what? A weight greater than that. So it means probability, if I'm to normalize it, Z is greater than 87 minus 82 over the standard deviation that we don't know like this. Are we together? Is equal to what? Is it equal to this percentage? Or what? Is greater than that, is equal to 22%. 22% is 0.22. We are told the percentage. But if we want to find this area, remember we said 1 minus. There has to be 1 minus, if you remember. 1 minus that, this area here, is probability. I hope it's making sense now, what I mean. So 1 minus this, so 1 minus the probability of this. And the probability of this we are given, can you see? So if I say 1 minus 22%, what do I get? 88 what? Percent. Makes sense? Because I'm saying 1 minus, okay? Probability
So
of, yes, Z.
it's 0.78.
Okay, 0.78, sorry about it. I just wanted to clarify certain things here so that we are clear with everyone is clear there. 1 minus this, that's what we're talking about, is equal to, so we're saying this is 0.78. So what it simply means is that phi of, we subtract, what do you get? 5, huh? 5 over S is equal to 0.78. Like that. Okay, this is 5 and this is S. Because we're saying the area to that is 78%. And what is 78%? Now you are given the probability. Huh? So you are looking into the columns for 0.78. What do you get? Let's use your tables and see what you get. Hi, how are you? Dream lesson. Wow, yeah. So 0.78, what do you get? 0.78. What do you get for 0.78? Or something very close to 0.78. What do we get? Maxine, what are you getting?
If we check the Z column by 0.7,
Maxine,
then check.
you are making mistakes here. You are forgetting that when we do that, when I say phi of something, let's say phi of 0.78 like this, I'm trying to find the probability. That's when I use this Z column. But this one, I'm given the probability. So I have to go inside.
I found.
Oh, that's what you mean. I have to go inside here. So what you're saying, yeah? Well, you're saying if you go to
0.7, and it's between where 0.7 and 7 meet, we have 0.7794. Then if we go to the add column, if we're to add 6, we arrive at 0.78.
Do we? What did you say?
Something close to.
What did you say? Your first 0.7 what?
We go to where 0.7 and 7 meet.
You get 0.7 what from your answer? You said 0.7?
794.
0.7?
794.
94. So you need to add 6.
Yes.
Oh, yes. So did you find 6 on the additional? Or 5?
It's...
What do you have on the additionals? Do you have a 5 or a 6? So that is very close.
There's a 6.
Yeah, so a 6, it's on which digit?
2.
On 2, huh? So which is giving you a perfect answer, which means it's 0. You said we went on 0.7, then you went on the 7, huh? Then where is your 2? Your 2 is on which? You said your 6 is on 2, huh? Like this.
Yes.
So this is your answer, which is very close for which is the answer in the marking scheme. So that's not difficult. So it now means we are simply saying 5 over our standard deviation is equal to 0.772. Clear now? Make sense? Then 0.772 S is equal to 5, huh? Then 5 S, sorry, to S. S is equal to 5 divided by 0.772. What do you get? You get 6.48. Clear?
To what extent is it like, okay, when they give you a question,
Yes.
how far off can it possibly be from the correct answer?
Now?
Like, okay, so you know how sometimes you won't get a perfect answer, but then to what extent can it not be perfect? Do you get what I'm trying to say?
It differs with the question. Huh? I think this one, it was plus or minus 0.228.
So how do I know when to? Because sometimes because what if I then answer a question and I find an answer thinking that it's correct, but it's because it's like slightly off the correct answer, but
No.
it's wrong.
You remember what
So that's
yes, I get your point, but I'm saying as long as, for example, this one, that's what Maxine used. Someone could have used what? Let's look at maybe at this as a good example, because we want 0.78. Huh? You remember your answer has to be very close to this. Huh? So if you go into that table that she was talking about there, she used that, which is perfect. Huh? Someone could have used a value. I want to see that your answer will see you still get the same answers. They will be close to. Someone could have used what? Let's go back and see if someone didn't get that perfect answer there. What could someone have used? That's my question. So that I try to answer you in terms of. Okay, let me go back a bit. So we want something very close to 0.78. Let's all go back to the table there. So she used that, which I agree with. So let's see. Try to how do I maximize this thing? Okay. Yeah, I now have my tab. So 0.78, someone could have gone to, you see, she used 0.7794. Okay, that's fine. I'm just thinking what could have someone used. 0.77. I want to look for 77, where I can also add and get an answer very close to. If you had used 0.7764, you would need to add 30 what? 36. Huh? But if I add 27, so you see, I can't because that's I'm just seeing what else could we have used 0.7. Unfortunately, that's the only answer that will give you an answer very close to 0.78. Yeah, your question is neither here and there, but there's always a degree of what, especially when it comes to tables, huh? Because someone could have used a calculator. A calculator is more precise. Huh? Like what I said, your Casio has got a way to do this. Huh? I'll send you, like if you're on the group, I'll send you how to use your Casio. Instead of using your that, you can actually use your Casio and find these values that we're talking about. But so it will be more precise because it will have more decimal places. But anyway, you know that from your syllabus, you round your answer. When it comes to this, you round your answer to 3 decimal places at the end of the day. So you get an answer very close. Okay. Okay, we'll see you next time. So just make sure you're on the group, then I'll send what I said on the group. Okay, enjoy your weekend.
Thank you, sir.
Thank you. Listen, Dave. That was it actually. It's okay. Yeah.
Mm.
Hi, listen. I'm good. I see my friend. Serious. Maybe it's the Andy I checked yesterday. Oh, sorry. No, I used to like it. I used to running long distance. No, okay. Normally when you want to do, yeah, I'm saying normally when you do that, you have to do it gradually. Do like one time to yeah, but I'm saying you go to 5, then 10 slowly. 5 to 15, that's a good stuff. Oh, mm, yeah. Oh, listen. Okay, thanks.